Okay, so I'm just continuing on summarizing what we have so far before we move into more tests. Remember, we have the test for divergence, the T4D. We're checking to see if it diverges or if I need to do more work. So if I have this sum and I take the limit of the nth term, right? A sum is different than a limit. So if I take the limit of the nth term and it doesn't equal 0, then I know the sum diverges. If the limit equals 0, nothing, got to do some more work, more test needed. So you will get either yes diverges or do another test, right? Do another test. Yes diverges or do another test. You will never say converge by test for divergent, right? That's a big bad no. All right, so this K rule, I'm just going to call it the K rule, is when you're taking limits of numbers to the nth power. And so I just want you to know it. I mean, there's nothing, you don't have to refer to it. This is just something I want you to know. If that number is absolute value is smaller than 1, you get a limit of 0. If the number absolute value is bigger than 1, you get a limit of infinity. Okay, so if you are taking a limit of the nth term out of a sum to find out if it converges or diverges, remember you're doing T for D. There's never a time that you're taking the limit of just what's inside unless you're doing the test for divergence. And the test for divergence, remember, says doesn't equal 0, diverge. Equals 0, nothing. You get nothing out of a limit equaling 0. Okay, so let's look at this one here. What do I have? Looks like I have a number to the nth power. Does it not? Let's look at this. So if I want to just fix this up here at the top, 4 to the n, negative 3 to the n, equals 1 to infinity. So what can you see here? Whoops, yes, that's right. So if I wrote out the first few terms, n equal 1, n equal 1, n equal 1, n equal 2. So I would get 4 over negative 3, 4 squared over negative 3 squared, 4 cubed over negative 3 cubed. I can see A is negative 4/3, and I can see R is negative 4/3. So since the absolute value is R is bigger than 1, I can see diverges by geometric. So that's one way. I wanted to talk about there's more than one way that this problem, not too many of them have more than one way. But if I want to look at this and I think, I'm going to try test for divergence. That means of this sum, I'm going to take the limit of the nth term. So the nth term is 4 over negative 3. Hey, that number is absolute value. It is bigger than 1, so that equals infinity. Doesn't equal 0, so the whole thing diverges by T for D. So you have options. All right, so this one you cannot split up, right? Other times you've split up fractions, but that's always with addition or subtraction in the numerator, not the denominator. So there's nothing you can do to split this up to use p-test on. What to do? Doesn't factor to be partial fractions to go find the sum. Plus, it doesn't even say find the sum. It just says converge or diverge. I do notice that the degree are the same on the top and bottom. Let's try T for D. If I take the limit as n goes to infinity, I take highest powers, 2n squared over 3n squared. The n squareds cancel, so I get 2/3. Doesn't equal 0, so it diverges by T for D. This one again, you cannot split up around subtraction in the denominator. It's not looking like I'm going to do partial fractions on it. Let's try T for D again. If I take the limit as n goes to infinity, highest powers, you see it, it's 2/3. Doesn't equal 0, so therefore it diverges by T for D.